Welcome to Leo Academy. Today, we're tackling LeetCode 135, Candy. This is a brilliant problem that perfectly illustrates the power of the greedy approach when dealing with local constraints that affect a global minimum. Let's dive in. The setup is simple. You have a line of children, each with a specific rating. You need to distribute candies based on two golden rules. First, every child must receive at least one candy. Second, if a child has a higher rating than their immediate neighbor, they must receive more candies than that neighbor. Our goal? Find the absolute minimum number of candies required to satisfy everyone. Think of it like a greedy candy store. We want to be as efficient as possible, giving out the bare minimum. If two neighbors have the same rating, they don't necessarily need the same amount of candy, only higher ratings demand more. The challenge is that a child's candy count depends on both their left and right neighbors simultaneously. To solve this optimally, we use a two-pass greedy strategy. Instead of trying to satisfy both neighbors at once, we break it down. In the first pass, we move from left to right, ensuring every child has more candy than their left neighbor if their rating is higher. In the second pass, we move from right to left, doing the same for the right neighbors. By taking the maximum of these two constraints, we satisfy both rules with the smallest possible total. Let's trace this with an example. Suppose the ratings are 1, 2, 8, 7, 3, 4, and 1. We start by giving everyone one candy. In our forward pass, we look left. 2 is greater than 1, so it gets 2 candies. 8 is greater than 2, so it gets 3. 7 is not greater than 8, 3 is not greater than 7. But 4 is greater than 3, so it gets 2. Our array is now 1, 2, 3, 1, 1, 2, 1. Now, the backward pass. We look right. 4 is greater than 1, but it already has 2 candies, which is more than 1. 3 is not greater than 4. 7 is greater than 3, so it needs more than 3's 1 candy, it gets 2. Finally, 8 is greater than 7. Since 7 has 2 candies, 8 needs at least 3. It already has 3 from our first pass, so we keep it. The final distribution is 1, 2, 3, 2, 1, 2, 1. Summing these up gives us 12 candies. In Python, this is incredibly clean. We initialize a candies array of size n with 1s. We loop from index 1 to n-1 for the forward pass, and then from n-2 down to 0 for the backward pass, using the max function to preserve our previous progress. Finally, we return the sum of the array. This approach is highly efficient, running in O of n time with a single linear scan in each direction. We use O of n extra space for the candies array. You've just mastered the two-pass greedy pattern. If you found this breakdown helpful, hit the like button and subscribe to Leo Academy for more premium deep dives into data structures and algorithms. See you in the next one.